Because it is weird to think of the idea of a robot swimming around in your lungs. It's not the algae cells part of it, it's the robot part of it that creeps me out. I'm going to add that to the list of things I never thought I would say. And in stranger news, how would you like tiny robots to treat you if you have pneumonia? I figured I'd go look around just for a little something lighthearted today. Well, maybe lighthearted is the wrong word. Might be slightly creepy. There are some days that I marvel at what we can do as scientists, and there are other days that I'm like, that just seems creepy. Courtesy of Science Daily, which is a handy little place to go sometimes if you're looking for some interesting science news. Tiny swimming robots treat deadly pneumonia in mice. So admittedly, this is not people, this is testing in mice. But, I mean, you can work yourself ahead because you could get to the point where you're using this kind of stuff in people. So, we can move ahead there with that and think about it a little bit. Just a touch creepy. Nano engineers at the University of California, San Diego have developed microscopic robots called micro robots. Part of me thinks you could understand they were microscopic, unless there's something else that's called a micro robot. I don't know, but I would think you could just say micro robot and most people would get it. That can swim around in the lungs, deliver medication, and be used to clear up life-threatening cases of bacterial pneumonia. Check this out. In mice, the microbots safely eliminated pneumonia-causing bacteria in the lungs and resulted in 100% survival. By contrast, untreated mice all died within 3 days after infection. Results published in September 2022 in Nature Materials. So it's a Nature journal. Microrobots are made of algae cells whose surfaces are speckled with antibiotic-filled nanoparticles. The algae provide movement, which allows the microrobots to swim around and deliver antibiotics directly to more bacteria in the lungs. The nanoparticles containing the antibiotics are made of tiny biodegradable polymer spheres that are coated with cell membranes of neutrophils. I have no idea what that is, which are a type of white blood cell. What's special about these cell membranes is that they absorb and neutralize inflammatory molecules produced by bacteria and the body's immune system. This gives microrobots the ability to reduce harmful inflammation, which in turn makes them more effective at fighting lung infection. Okay. On the one hand, it's brilliant. Don't get me wrong. On the one hand, it's brilliant. Tiny little things loaded with antibiotics. You get an injection of it, perhaps. You give the mouse, in this case, an injection of it that's sick with pneumonia. And the little things swim around and hit the bacteria in your lungs, the pneumonia-causing bacteria in your lungs with the antibiotics, and pneumonia bacteria dies and mouse lives. Fascinating. Really, really, really fascinating. And at the same time, that's really freaky. I always get uncomfortable with the ideas of doing this kind of level of treatment and the kinds of things it leads to when you're thinking about, potential for human beings accidentally playing God. That's kind of where I get a little nervous with some of these things, and I mean, strange science is definitely where this one fits. Very, 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 very strange to me. Anyway. Oh, goodness. The work is a joint effort between the labs of nanoengineering professors Joseph Wang and Liangfeng Zhang, both at UC San Diego Jacobs School of Engineering. Wang is a world leader in the field of micro and nanorobotics research, while Zhang is a world leader in developing cell-mimicking nanoparticles for treating infections and diseases. Together, they have pioneered the development of tiny drug-delivering robots that can safely be used to live in live animals to treat bacterial infections in the stomach and blood. Treating bacterial lung infections is the latest in their line of work. quote, our goal is to do targeted drug delivery into more challenging parts of the body like the lungs. And we want to do that in a way that's safe, easy, biocompatible, and long-lasting. And that is what we've demonstrated in this work. Maybe so, but I mean, this is one where you got to think carefully about some of the implications and sometimes potential misuses and what have you. And there is reasons we have the thing with like there is a reason where we have to think about these things. This has obviously not been tested in humans yet, but it's certainly interesting. And I mean, I'm trying to think of this. If I were dying from some kind of pneumonia, then maybe I might be okay with it. But at the same time, I'm also like, little robots swimming around in my lungs. Do I really want that? I mean, that's kind of what I'm thinking about right now. It's just like, do I really, really want little tiny robots swimming around in my lungs? It just sounds... don't get me wrong. It's amazing. It's obviously breakthrough technology, and I don't understand all the little things in here. I will probably go read the paper at some point and be like, okay, I'm going to need to check definitions, so make sure I understand what's going on here. Which is part of the thing. If you're reading a paper with which you are unfamiliar, you got to check the definitions and what do they mean in the field when they are talking about these things. But creepy is one of the words that comes to mind, as well as brilliant. This is one where I'm kind of torn, because it's creepy and brilliant at the same time. The team used the micro-robots to treat mice with an acute and potentially fatal form of pneumonia caused by the bacteria Pseudomonas aeruginosa. Pseudomonas aeruginosa. I think I butchered the pronunciation, but anyway. This form of pneumonia commonly affects patients who receive mechanical ventilation in the intensive care unit. The researchers administered this micro-robots to the lungs of the mice through a tube inserted in the windpipe. The infections fully cleared up after 1 week. All mice treated with micro-robots survived past 30 days, while untreated mice died within 3 days. So, commonly affects patients who are mechanical ventilation in the intensive care unit. Admittedly, we had a lot of folks who were on ventilators when they had severe cases of COVID. So I mean, I immediately wonder, is this potential breakthrough for any other COVID-like diseases? You know, things like that would be interesting. But anyway, treatment with the right micro-robots was also more effective than an IV injection of antibiotics into the bloodstream. The latter required a dose of antibiotics that was 3,000 times higher than that used in the micro-robots to achieve the same effect. For comparison, a dose of micro-robots God, this just sounds strange. Anyway, a dose of micro-robots provided 500 nanograms of antibiotics per mouse, while an IV injection provided 1,644 milligrams of antibiotics per mouse. The team's approach is so effective because it puts the medication right where it needs to go rather than diffusing it through the rest of the body. And that is the thing with medications in the bloodstream, is that they do diffuse through your body rather than going to the place where they are needing to be targeted. Memory serves me correctly, they've had a similar problem in the past with chemotherapy and radiation treatment, where they would just do radiation treatment and end up on the whole body and hope you got the cancer at the same time. And in recent years have developed more targeted methodologies. I am not the medical doctor on that one, so for the medical doctors out there, you can correct me if I'm wrong on that one. For sure. Let's see. These results show how targeted drug delivery combined with active movement from the microalgae improves therapeutic efficacy, said Wang. Quote, with an IV injection, sometimes only a very small fraction of antibiotics will get into the lungs. That's why many current antibiotic treatments for pneumonia don't work as well as needed, leading to very high mortality rates in the sickest patients, said Victor Nezet, professor of UC San Diego School of Medicine and Skaggs School of Pharmacy and Pharmaceutical Sciences, who is a co-author on the study, and a physician-scientist collaborator of Wang and Zhang. Quote, based on these mouse data, we see that the microrobots could potentially improve antibiotic penetration to kill bacterial pathogens and save more patients' lives. If the thought of putting algae cells in your lungs makes you squeamish, it's not the algae cells, it's the tiny robots that actually makes me squeamish. That's a whole other thing. The researchers say that this approach is safe. After treatment, the body's immune cells efficiently digest the algae along with any remaining nanoparticles. Nothing toxic is left behind, said Wang. Oh, that's interesting. Well, I mean, that's nice to know that nothing toxic is left behind. You're still talking about a micro robot, though, which is just strange. Although maybe some kind of if the authors of this hear me at any time, a thought maybe to try is actually what's because usually when somebody hears robot, and maybe I myself am thinking this, they think they are hearing, how do I put this? They're thinking of mechanical thing moving around that has a lot of metal and electronics in it and what have you, and that's immediately where I went to. But you're talking about a micro robot where that would be very difficult, I would presume, to do that. So maybe it's perhaps some education on the difference between a micro robot and a traditional old-fashioned robot that probably most of us are thinking of is probably relevant here. Because it is weird to think of the idea of a robot swimming around in your lungs. It's not the algae cells part of it. It's the robot part of it that creeps me out. I'm going to add that to the list of things I never thought I would say. The work is still at the proof of concept stage. The team plans to do more basic research to understand how the microrobots interact with the immune system. Next steps also include studies to validate microrobot treatment before and scaling it up before testing it in larger animals and eventually in humans. Study work supported by National Institutes of Health. Okay. Like I said, I'm just going to leave this one brief because I think it's fun. It's creepy. It's brilliant, but it's creepy as I'll get out. And like I said, it's not the algae cells. It's the robots part of it that's actually more creepy to me than anything else. Let me know what you think. Would you like robots swimming around in your lungs if you get sick? Let's go there. If you like this video, hit the like button on the way out the door, comment on the video, share the video, subscribe to the channel, all that lovely good jazz. And until next time, I'm Adrian. Stay curious, everybody.